Hello there. Welcome to this episode of the Shieldia blog, where I will go through the damn vulnerable web application, structured query language injection on low security, but the blind SQLi, one of the challenges. This one is a bit more difficult because the DBMS doesn't return any data back as to whether or not our payloads have succeeded or failed. However, there are commands that we could run on the database that would then let us infer if these commands have successfully executed, namely the sleep command. What that does is, like most Unix operating systems or POSIX or whatever you want to call it, sleep will initiate a wait period for a set number of seconds by default. So sleep 5 within the DBMS would make it sleep for 5 seconds to oversimplify it, which then the browser would experience as a delay. I say the browser or whatever other instrument you're using to interact with the database. So today you're going to need some prerequisites if you want to follow along at home with the Tartarus lab. So there's the red team setup that'll bring everything up from the red team perspective, and then the blue team setup that'll bring everything up. You're gonna need a bit more resources if you want to bring the blue team side, because that incorporates the seam and some other aspects. So without further ado, this is a bit of a flow diagram as to how the attack will happen. What we're going to want to do is the preamble to get a valid PHP session ID. Then we're going to want to attack the specific parameter that's vulnerable. Here, in this instance, it's ID. So ID equals 1, and then the payload. Now we will wait for the response. Either it will be delayed by 5 seconds, indicating that the attack was successful, or it won't be delayed, indicating that the attack failed. As always, we're going to go through with the basic browser. So I will log in the Kali guest to the damn vulnerable web application. And as always, we'll use the admin account because lazy. We're going to then change the security level to make sure that it is low. Submit. Awesome. So now all the way down at SQLi, we will input, let's say, a valid user 1. Now all we are getting is that the user exists in the database, or let's say -1 is missing from the database. So that would indicate that maybe there was an error in the back end, but all the application is telling me is that user ID is missing from the database. So with that in mind, let's go through and see how we would be able to exploit this. So what we think the parameter is doing is this in the background. Select user ID from the table users where user ID equals what we're inputting, the variable. So if we change that to be a command, a valid SQL or structured query language command like sleep, what does that do in the background? Now watch, I'm going to do an inspect element. So normally the responses should be almost instantaneous within the network pane. The time, 26 milliseconds, almost instantaneous. However, if we do it with the sleep command, you'll notice two things. This is busy thinking, and then over here we will see, that's taken 5,000 milliseconds. What is 5,000 milliseconds in seconds? 5 seconds. Awesome. So now we can see, user ID missing from the database, but that doesn't really matter because we have executed valid SQLi on the server and then return that result, return the response from that. We can then chain that together to be able to exfiltrate information with true or false statements from the database. Another tool that you could use is fuzzfoster to be able to identify if the variable is in fact injectable and what payloads would work on that variable. So open a terminal. First, as always, we populate the PHP session ID variable within our current scope of this individual shell session. Say that 5 times fast. Next, we're going to then run the fuzzfoster command, which would be, if I can click, There we go. So first to be full, the target URL, Tartarus, as we've set it within our host ECC host file, so that it will always point to the IP address. Then the directory that we're targeting in this instance, fuzz being the keyword that we're going to be replacing, ampersand submit equals submit. We're also doing the pen code thing where we are making sure all of the input strings within the payload is URL safe. So firstly, I'm going to control Q to save that command to the queue. And I want to make sure that I have the SQL injection payloads list downloaded from GitHub, which I do have that directory. So that's where the payload will reside. Then we're going to do a match time for 5,000 milliseconds. So I think that's due to a formatting error, is it? Match time. Why do we have it like that here? Well, okay, we'll leave it as is. We'll see if I do actually need the backslash there, and then timeout of 100, and then just one thread of this, because we don't want to do any multi-threading. Even though FuzzFuzzyFool is really good at that, we don't want to do that in this instance. So we're testing each one individually. There we go. We can see some successful payloads there, another successful payload, and then we can wait until all of the payloads have returned. I mean, it's only 95. It's not really a long list, but doing them one at a time does slow down FuzzFuzzyFool quite a bit. So I will skip ahead until we have all the payloads. Now that all the jobs have completed, something to take note of is the return status by the application. Here, for instance, we get a 404, and here we're getting 200s. It is the application itself making these decisions. Even though we're getting a 404 here, they are actually successful because there is a delay. It's only the application saying, that ID doesn't exist in the database. To exemplify this, we will say ID1 and look at the response code. It's 200. ID that gets a 404. It's just the application telling you, hey, the ID isn't in the database. So it's missed the programmer thinking, oh, we'll just do it in a status code as well. Even though, does that go against spec? I mean, if there's an API, maybe it's a different story, but as a web page, does it go against spec? I don't know. Just something to be aware of, because that has tripped me up in the past when dealing with some of these requests, as in some of the detection logic for it. So you can see here, that is a payload that will work, including, don't forget about the ID parameter. We can then throw that in a cyberchef just to exemplify, no, not .org here, and then we can link to it from there. Sneaky people. Sneaky people. Even though you can freely host it, I don't trust them. I'll only trust the GCHQ one. And then you can do a URL decode. Throw that in there, and select all from sleep. And then that's just a variable that it's throwing in there from, so that doesn't really matter. Like a random variable. But sleep 5, we can see that successfully executes. So we know that this page is vulnerable. Moving on to a more advanced method, you can do all of this in Python. So me and everyone's favorite ChatGPT came up with this code to be able to exfil all of the necessary information from the target. We will then quickly do a nvim. It's not installed on here. Oh, that is sad. That is genuinely sad. That's sad. Anyway, I'll just throw it in vim and then we can have a look. So vim test.py, and then we'll input everything. So it's not as great syntax highlighting here, but bear with me. We'll be importing quite a few arguments. So argparse is great so that we can just pass it arguments from the command line. We don't have to stipulate things within the file itself. because I'm lazy. Then time requests to be able to do the actual HTTP requests, time to be able to test some of the delay stuff, string and RE for some of the searching, and then the libparse stuff is needed for how some of the characters can be formed within the URL. Now we have a few of the functions. Parse arguments just passes all of the required arguments. So in this instance, basically target URL. Then we get the cookies. So you will note we have the way that the damn vulnerable web application is setting all of the security levels is via the cookies. So here we would just get the URL, and then we want to just get that as respond with it, so that we can load some of the things that we need, for instance, the PHP session ID. So here we can set all of that, the cookie jar to security low, and then as we progress through these challenges, it's easier to change this to medium and high later on. And then we do a with, the new with sort of keyword, so that we can then make all of these requests to the web server. For instance, here, this is setting up our initial login like we do within a nuclei template. And then later on, we can do all of our attacks against the specified parameter. So here we go through. So this is the payload that we will be using. And then there is a loop here. So 4 chars in the ASCII letters and digits and an underscore, because that's how the table names are. That's basically all of the valid characters within the table names. We will go through 4 char in that injection payload. So then that builds the payload, and then the encoded payload, because we have to do quote plus because some of the characters are not URL safe. Then we get the full URL from that, and then we will see if the start time and the response time is greater than 2 seconds. We will know that the request succeeded. I've put 1.9 just to be safe. You know that the request succeeds. And then you do that for a few more iterations for some of the different target payloads that we need to inject, so that we can get as much information from the database as we can. So I'm going to do a, no, that's going to be u, so that it's the actual file. We're going to write that file, and then we're going to do Python 3 test.py, and then the target URL. I just want to make sure that we are formatting it in the right way. How are we calling it here? So it is just, yeah, target HTTP this download web app .home .arpa download web app. Cool. Wait. Oh, do you have to give it the entire thing? You have to give it the whole URL. I didn't think I would need to, but we'll give it the whole URL just to make sure. Qu'est-ce que c'est? Qu'est-ce que c'est? Test. Then we just do a help and then see if we're formatting it correctly. Oh, okay. Login. Oh, because it, yeah. PHP. There you go. So now it's finding the characters because there is that weight that it's experiencing. So the database name is damn vulnerable web app. We're not using the database function within the DVMS. Instead, we will be able to extract it that way. Now we can extract some table names. So this one would be guest book, and then comments, and then some of the other ones. So you can see how we'll slowly iterate through. So it's trying A, B, C, D, E, all of these characters until it finds one that succeeds based on the payload. If we were to look again at some of the Python code, that will be here. So the injection payloads, is that the first one? Yeah, that is the first one. So the injection payloads would be that, and then your target URL. So then, let's see. There you go. So there's your sleep and everything else. And then that's how you go through that one step at a time. So as I was explaining before. Now, yeah, guest book, and then now column names, comments, and all that stuff. So we don't need to sit here and go through because it takes forever. But that gives you an idea of how you can also use Python to then automate the process of extracting information from the database once you have confirmed you have a blind SQLi, or once you have confirmed you can in fact run arbitrary commands on the server. Moving on, we have the classic SQL map. There was a mistake in this initial command here. What SQL map's smart enough to, it saves the slower stuff for as a last resort. So in this case, time-based SQLi is actually quite slow. So instead, what it will do is it'll try other methods first. So you have to specify what technique to use. So here technique equals T for time. And then that says, no, only use time-based SQLi in this instance. So we're going to populate another PHP session ID so that it refreshes our session. And then we will use this SQL map command instead of the other ones, because it doesn't actually work. Now it'll do, what it needs to do for us, and we can just sit back and relax. And again, if it's in bold, like if it's uppercase, you just press enter and then that accepts the default value. And then, yeah, that'll go off and do it for you. We can instead look here, and at the end of what it will find is this. So you'll find some hashes and you'll basically get all of the information that you want out of it. So, yeah. Moving on to the blue team perspective, which will be in a little bit. I will see you there. Hello there. Welcome back to the blue team perspective of the damn vulnerable web application blind structured query language injection on low security. In this part of the video, I'm going to be describing some of the detection methods that we can use to identify if these attacks are happening, and more importantly, if they have actually succeeded. Firstly, we want to look within Elastic. So you must have the blue team perspective prerequisites already met, and then have ran these tests with the seam active. So the Tartarus Elastic seams where we're going to go. We can then start to look at some of the alerts, which would already be firing for this activity within your environment. However, there's something I do want to just note briefly, is that within the rule logic, there are some issues that I ran into. For instance, within the Sigma rule, there was already a filter to filter out 404s. However, as we have discovered, the application actually answers with successful requests to a 404. So I had to just remove that part of the Sigma rule and then convert it into an Elastic rule so that it can actually be used. So just go rid of that filter. As I was saying previously, that's just some of the issues that can be experienced when running this stuff. Again, we'll go to alerts and see what we're saying. There should be some sleep-based SQL injection strings in URI. Awesome. So that includes sleep as one of the strings. It doesn't directly call it out as its own alert because it is, at the end of the day, SQLi. Now, how do we tell if these attacks are actually succeeding? For instance, here, all our selection is quite limited. It's not necessarily that it's going to get all of this information. So we're doing here an ESQL query for that within the URL. So where HTTP method get, and because get is safe to use here because the response that we would be interested in is within the message returned, the return message body. It's not just within the status codes, for instance. So head-based obfuscation wouldn't necessarily work here. However, there may be some post-based obfuscation might work. Could be interesting. Need to test that later on. Instead here it's saying we're query like all of these parameters. So something interesting to think about. Then we'll do a eval time buckets and then all of that stuff. Now, how do we know if these attacks actually are succeeding against the database? The only way that I've found that actually experiences this delay is the browser in question. I've looked at the firewall logs. Within the firewall flows, there is nothing that differentiates if this attack has actually succeeded or not. The TCP connections will always happen at the same time. They do not wait 5 seconds. It is only the browser or whatever application is used to interact with the DBMS. That's the only thing that actually experiences the delay. I want to make that crystal clear. So there is no other method that I could identify to be able to successfully say, yes, this sleep-based SQLi is working. As opposed to it's just happening. It can just happen anywhere, anytime, and do anything. That doesn't really matter. What matters is, yes, it's happening and it was successful. That's a key differentiator that will take you to that next level. The way that I found to be able to visualize this, because is the easiest, is through the Vega scheme, which is a visualization library that Elastic provides. There's no, now maybe with some of the more join queries, we might be able to do it within natively in ESQL. That would be cool, but I just haven't invested the time into perfecting that within the Elastic 9.0 or 9.1 at this point probably. Instead, we're working with 8.13 or 8 point whatever. I haven't updated to this whole entire everything to 9.0 yet, which that gets some of the more advanced ESQL stuff within GA. But we're not going to bother with that at the moment because there's something that does actually work, and that's the Vega search. What we're going to want to do is copy this whole piece of JSON. Then we're going to want to go to, has that just moved it to another window? Yes, it has. Awesome. Then you go to the visualization library. Within here, we're going to create a new visualization, a custom visualization, and then input our JSON code here and update. Now, this is going to be for the last 50 minutes, which is not necessarily what we need. For now, we can do the last 20 minutes and update that. And then you can see why I've called this, quite kindly, the sleepy porcupine, because, for instance, here, this is the first request. So it's going to go A, B, C, D, 4 requests. A, B, C, D, E, F, blah, 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 to get to the other characters within the list that it's trying. And then again for D, V, W, A, all the way down there. And then it goes through all of the characters. Doesn't find anything, so that doesn't work. Then iterates through it again and again and again until it finds a successful character. Iterates through it again and again until it finds a successful character. And then could iterate all the way through, all the way. There's 100 requests in that instance. 100 requests per second, so that doesn't necessarily, but you get the gist. So then it'll go through all of these requests. I'll hit it with another refresh just to see if this, is that going to taper off? Okay. And then it'll go through all those requests every time, trying a different letter to see if that succeeds. So this one is very spiky because we're trying it from, we're not doing what SQL map does, which is from what I can see is a binary search. So it'll try Is it this side of the alphabet or that side of the alphabet? And then slowly, well, I say slowly, much more quickly narrow it down. And the delays are much longer. So here it's saying it'll try A, it's not A. It'll try B, it's not B. It'll try C, it's not C. It'll try D, and then it'll delay for 5 seconds. And then it'll try again. And then it'll try again. So you can see how I've come up with the way where it sees, okay, it succeeds, waits for 5 seconds, and then tries requests again. Succeeds, wait for 5 seconds, and then tries requests again. So we can, just by looking at this graph, say, yes, the SQLi is working and it is pulling data out of the database, as opposed to manually going through each and every log within the apache.access. We can instead say here, no, 100%, it is pulling data from the database. So that's something we should be concerned about. Here, it's pulled everything that it needs from the database. So it's pulled the D, V, W, A, and then it tries all of the other characters, brrr, fails. Now, guest book, and then users, and then, okay, that's all it's found, brrr, tries everything again, finds nothing, and then moves on to the next for loop. And then the next for loop is all of these values here. So you can see the database name, the table names, and then the column names. And then what you'd be interested in is user and password. And then that, going further and actually extracting what's in those columns, would be the next logical step for the script. However, SQLi already does that for us, so we don't need to do that. Moving on, so that explains sort of how you can use other visualization schemas to be able to tell, yes, these things are in fact working. Moving on, you could do it with SQL map, and what it would look like is a much more flat. It's not as spiky as before. It's not, because it is only doing the binary based search, so therefore it's doing a lot less requests per second, and it's not waiting 5 seconds every time. It's waiting in the range of something that's a bit more variable, so it's much harder to detect. However, it is still spiky. Now, and you're saying query equals sleep, it's definitely something that you're going to want to look at. Obviously, in production, this would be tweaked and changed so that you could look at individual servers from specific source IP addresses and all that. I'm not going to worry about that now because mainly a proof of concept. Then, Nassim, no problem. You can look at all of this information is contained, because it's doing all of the requests via GET within the Apache access log. We can then look at it, go vig. We can go vig rent sh down on a web app, and then that'll give us all the information that we want to look at. We can clear the screen. So now we're definitely within the guest machine. We can paste this command and then see all of the access logs. RIP bitrate, I know, don't worry about it. But all of these, so down vulnerable SQLi blind, and then that's the command that it's attempted, etc., etc. So you can get all of this information from the server if you do not have it already collected in a seam. Because as long as the adversary hasn't cleared the Apache access logs, you should be good. If the adversary clears these access logs, there are some issues that I've found within how Apache handles that. But that's a topic for another time. Moving on, and then as it says here, you use Python and the pandas, the sort of mathematical module. Well, not module, I say module every time. It is like an import, so that you'd be able to do more fancy mathematical operations on these. We don't need to do that at the moment. Vega provides just enough of functionality for what we need today, so that we don't need to worry about it. Then we can move on to the Purple Team perspective for how we can automate a lot of this activity. So I'll see you then. And if by magic, the Purple Team perspective of the damn vulnerable web application SQLi blind on low security coming at you right now. We're going to then, it's very simple, this one. Well, I say very simple. It's simple once you know what to do. All we're going to be implementing is a DSL match within SQLi so that we can successfully identify if there is a 4-second match in the commands that we are running. To exemplify what that would look like, we can, within here, look at cd vagrant. We can look at the specific template file, which would be cat temp. Oh yes, SQLi templates, damn vulnerable web app, SQL blind, and then low security. Here we go. So as these have done before, we are doing the variable and using the flow method. We first basically log in. So we have get login to populate the page, to populate the token successfully. Then we can do a post request with that specific token to be able to log in. Then we set the security level to what we want. In this case, the security settings will be low. Finally, we know that this payload will succeed. So we're not doing a sort of fuzz to look at all the different payloads that could possibly succeed within this template. That's not necessarily, in my opinion, what these would be for. These would be for high impact, bang, we know that this will work, so we'll try it. One shot. Then the DSL, so the domain specific language query, is duration is greater than or equals to 4 for 4 seconds. And the status code is 200 or 404. As we know, 404 in this instance doesn't necessarily mean a failure. Then we can do some extractors and make it look good. So what would that look like when we run it? We can do a copy and paste job and have a look. Boom. I should have ducked it, but alas, I didn't. So now it might download some template files. Be unfortunate, but we can actually, no, I'm just gonna duck it. Why duck? Don't bother looking at anything. Just run what I say you're gonna run, and it will be happy days. Happy days. There we go. So it has scan completed in 5 seconds. It gives us a clue as to the fact that this has taken much longer than it would normally take. These things normally take almost instantaneously. It's taken 5 seconds, indicating duration above 4, so it has succeeded. Great. Now, how can we take that template and then utilize it in the Omega CLI so that we can actually do something a bit more productive with it? Not to say that this is not productive, but something just a little more productive. So we're going to the Omega CLI directory, so you can download that from GitLab, from my GitLab. Then the specific template that we're going to be testing today will fire that, and then it will look for the specific rule. So SQL injection in access logs. We can see if this is going to work. Place that in there. And again, we're using the debug flag and the config flag so that it will be able to successfully pull the config from a configuration file as opposed to passing everything we need for that config in the terminal. So it pulls the API key, it pulls the target, all of that gets pulled just from that one .m file. So you can actually confirm that it exists .env. And there it is. So it does exist, and it will be populated with all of the credentials. Obviously, in production, that would be something you'd pull from a password store. We're not going to worry about that. Ooh. Ah, yes. That is an issue. So if you ever get this certificate expired, it's an easy fix. It may be a little bit daunting, but it's an easy fix. On the host system, it's a print SSH elastic, and it's as simple as restarting the service, because we do certificates. The certificates they expire after 24 hours. So they get renewed very frequently, much more frequently than you would do normally within production. Yeah, a certificate that's going to last 200 years. Where's the security in that? Instead, these certificates are very much short-lived. However, that comes with a small downside is, in these instances, it can sometimes fail. To remedy that, it'll be a sudo systemctl restart caddy. That then should reinitialize the Acme protocol so that it will refresh the certificate, as in it'll get today's valid certificate, in theory. Cool, so there's no certificate warnings here, therefore I suspect it has succeeded. So we will run the template file yet again to see if that worked. Execute. We'll run it again with a bit of a cleaner screen, so it's not like 1,000 things going on. It's just what we care about. YAML file is valid, target is up, sleep has worked. Now, as in the nuclei, sleep has worked. Now we wait the it'll do an attempt every 15 seconds. Again, sometimes there is a delay in the logs getting to Elasticsearch. This accounts for that, and there we go. It successfully queries it and finds those alerts would have fired in the preview endpoint. Great. So everything works, and I believe that is all for today. Yes. Thank you so much for joining me, and I will see you in the next one.